I made a game from scratch in C++ using as few third-party libraries as possible. In this video, I'll go into how I did it and how you can too. This video is just going to be a quick summary of how the game works, and I might make more detailed tutorials depending on how well it does. If you've never made a game without an engine before, the task can seem pretty daunting. Where do you start? Well, here. This is the entry point for my game. It can look different if you're using a library like SDL, or making it for Linux, but in my project I'm only using the Windows and Vulkan APIs. From here I start up everything, start the main loop, and then shut everything down. You can see all the code for the game is wrapped in these try blocks. That's something I just like to do so that anytime I get an unhandled error, a pop-up window appears. I'm not going to pretend like my organizational choices are normal. I prefer to have global functions inside namespaces to separate the different systems in my project rather than classes. I know this goes against conventional wisdom, but I just like it that way. Anyways, the init function starts up all the other systems. I have it set up to create a console window when running in a debug build so that I can see log messages in a nice convenient place. In release builds, this console isn't here. I also have it set up to detect and print any memory leaks into the console when the game exits. This is the code to create the window. It basically just calls the create window function and sets up parameters like the icon, window size, all that. I've also got functions to toggle full screen and a window process that handles inputs, tracks the screen size, and hides the cursor when you're in full screen mode. The game renders to a fixed resolution of 320 by 216, and the geometry is split up into 8 by 8 tiles. But it doesn't just display the rendered image on the screen. With most window sizes, that would cause the final resolution to mismatch slightly with the 320 by 216 render image. So instead I have it pick the largest multiple of the base resolution. This can cause the game to sometimes be smaller than the window itself. I won't get into the rendering too much, since even though it's really simple, it's easily the majority of the code base. Vulkan just takes up a lot of lines of code. But the essentials are that a fragment shader renders the level using a texture, representing which tiles are at which locations. The fragment shader picks tiles from one image and renders them. This means that an entire level of whatever size would only be one draw call. All the sprites in the game are stored in one big PNG file. This includes animation frames, tiles, and even the end screen image, as well as a test sprite. And because I'm not using any third-party libraries, I had to write a PNG loader to load the sprite's image. My engine has a very simple implementation of entities. There's this base entity class that contains the position, sprite index, and dimensions of the entity, and entities are stored as pointers in this global entity array. The rendering engine renders all entities the same way, just a quad with the correct sprite and size. There's also an option to flip the sprite. The different entities in the game override this base class and override the virtual tick function. For example, the player contains code to check which buttons are being held down and to move, and the coins contain code to change their sprite for their animation. The level is stored in the stupidest way possible, as an array of numbers that I painstakingly had to put in by hand. There's no sound in the game because I'm too lazy to write a WAV file loader, even though it would be much easier than a PNG loader. The game loop itself is tied specifically to a 60 FPS frame rate. That makes it so that every frame that's used for input is displayed on the screen for maximum accuracy. I also render without any buffering for the lowest latency possible, while still avoiding tearing. But if you ever get below 60 FPS, that makes it immediately drop to 30. So to account for this, the game will only render every other frame. Anyways, that's about it. It was a lot of work for a very simple end result, but I learned a lot from doing it.